Alright, we're back in our trusty IDE, and we're going to take a look at a sample persisted event service. Before we look at the actual service itself and how it's been implemented, there are a couple of abstract-based classes that were mentioned in the Quick Start Guide that we should take a quick peek at. The first is the abstract multi-threaded event service. Here we can actually see that we have an event thread pool size that is a parameter that ultimately is passed in from the objects.yaml file. The event pool thread size controls the performance of the audit of the event itself. We can see that the abstract multi-threaded event service actually extends the abstract blocking queue service. Now, both of these abstract classes are part of the Apache licensed and open sourced framework that makes up the Objects Core server. The abstract blocking queue service has a default thread pool size of 3, and it does rely on a blocking queue to actually provide that separation between the client that's submitting the event or the object to be processed and the event runner that's going to actually do the processing of the audits itself. We're not going to spend any time going through the actual code in these classes because they are open source and available at our GitHub site with the framework. Simply clone the Smart Cosmos framework and you can review the full implementation of these two base classes on your own. However, what we do want to look at is the persisted event service that is the default implementation. Here we can see the persisted event service extends our abstract multi-threaded event service. It provides a static UUID as well as a human readable name, and it implements the sole method of record event. In this case, the record event takes the 4 constituent components of the audited recordable event: the event type, the possibly null iAccount, the possibly null iUser, and then the object source as well. And it puts those into a recordable event, and it places that into the blocking queue with a put. At this point in time, the record event will return back to the caller, so we can actually see just how fast, how little latency there is in the persisted event service, and how this implementation helps the callers get their response back from the server as quickly as possible without having to wait for a full audit event to take place. Ultimately, because this is a blocking queue, we need to have a runner over here that's actually going to process this. And we can see that we extend the abstract interruptible runner, which itself is also part of the extension API. So that code can be reviewed on your own as well if you clone the Smart Cosmos framework project from GitHub. What we do inside of the run method is pretty straightforward. We create a session with our database. Because we are on the other side of a blocking queue, we have no guarantee that the @UnitOfWork annotation on the actual REST endpoint will have any effect on us. In fact, we're almost assured that we will not be within the context of a database transaction by the time this event runner kicks off. Therefore, it's imperative that if you use this design, you must understand and appreciate that you are responsible for using the session factory to both open up your Hibernate session and close your Hibernate session and commit and roll back accordingly. We use the Hibernate context, the managed session context, and we bind that and begin our database transaction. We then proceed to go through the event DAO. You'll notice that we don't talk to the tables in the database directly. Even though we're managing Hibernate ourselves, we do not violate or pierce the veil afforded to us by the DAO pattern. We grab the event DAO, we create a brand new event, and you'll notice that we actually look to see if the instance of the recorded event is an authenticated user or not. If it is an authenticated user, then we want to make a copy of that user and use that copy in the record for persistence reasons. We also need to grab the type, and then again, we're smart about our nulls. Even the source theoretically could be null. in which case we need to properly look at that before we run it through the JSON util. Finally, the insert method is called, and we actually insert the audited event into the database. And at that point in time, we're able to determine if the persisted event should be broadcasted or not. Here we can see that if it's not suppress broadcast, then we actually invoke the broadcast notification method. Finally, we commit, and then post-commit, we actually process the visitors as part of the event pipeline. This sequence of events is critical to honor in any custom event service implementation. Number one, you need to persist the audit event. Then you need to look and determine whether a suppress broadcast has been requested, and if not, forward that over to the notification handlers via the iEvent broadcast notification. Finally, after the commit, we process visitors. A failure to honor this sequence could result in an implementation that creates ill-advised or unsupported behaviors within the server itself. Lastly, if we take a look at the broadcast notification event, we can see that the only thing that it actually does is it goes to the context, to the service factory, and it grabs the concrete implementation of the installed event broadcast notification service extension. It then invokes the broadcast event method, leaving it up to that event broadcast notification service to determine what the next steps are. Now we're going to take a look at a concrete implementation of an iEvent broadcast notification service. The iEvent broadcast notification service is effectively a controller for determining if a iEvent that has a suppress broadcast flag set to false, in other words, it should bubble through for integration, should be forwarded to one or more iNotification endpoint definitions for processing by the iNotification service. There's a lot of moving parts there when you think about that description. Let's start at the beginning. First of all, this is a service, so it extends the abstract service-based class, and it implements the iEvent broadcast notification service. Like all good abstract services, it provides a UUID and a human-readable name for the constructor and the super. Next, the broadcast event method is where all the magic has to happen. And in the case of the default objects event broadcast notification service, it looks to see if the account is not null. And this is an important check because the notification endpoints for integration are mapped at the account level. So if we have an event where the account is null, it's illogical to think that that event can be integrated with a third-party service. The reason for this is that the objects server is a multi-tenant server by design. So every event that fails to define an account also has no way to actually look up a default set of notification endpoints that should be forwarded as a set over to the notification service. If we do have an account, then we're able to go into the DAO factory and request all of the notification endpoint definitions for the specific account associated with that address. Once we have that collection of notification endpoints, we look to see and check that we aren't creating a circular or never-ending set of broadcasts. Because we do audit that a notification broadcast occurred within the iNotification service, we need to check and verify that the persisted event is not of type notification broadcast. Any failure to make this check will result in a spiraling out of control call stack and will never stop ending up broadcasting these events. We iterate through each of the notification endpoints that were associated with the account, and we take that endpoint and we actually go to our notification service and we publish to that endpoint the JSON related to the persisted event, and by default, the default objects event broadcast notification server sends over the minimum view of that persisted event. Here's a good example of where a custom event broadcast notification service extension could add a lot of extra value or bells and whistles that would allow administrators, for example, to define different levels of generation views based on a particular event type within the persisted event. In summary, the iEvent broadcast notification service is a controller. It has a responsibility of looking up the account and determining, based on the account, potentially as well as the event type, and the other details about the event, which notification endpoints should be notified via the notification service and which should not, or be thrown on the floor. Finally, the iEvent broadcast notification service implementation may decide that it's not necessary to use the actual notification service. If the implementation that backs this does not fit into a pub/sub message broker model, the default design for the notification service, then it's entirely permissible for the iEvent broadcast notification service to take matters into its own hand and actually do the integration piece within the broadcast event. However, in doing so, it's important to understand that if linked to the default persisted event service, this could create some serious processing latency, and it may be wise to introduce a blocking queue or another multi-threaded technique in the broadcast event so that there is no unexpected server performance hits in doing so. In this lesson, we're going to be using some open source extensions that are already available in GitHub. If you go to github.com/smarttracktechnology, all one word, you will find a number of public repositories out there. These repositories will be used in this lesson in some way, shape, or form. You might want to take a moment now before you continue this lesson and download these repositories or clone them to your desktop. Here we are inside of our IDE again, and we've downloaded or cloned from our public GitHub repository the AWS Notification Service extension. When we're looking at iNotification services and what exactly they do, this AWS notification service provides us with some insight into how a notification service should operate. First and foremost, we can see here how we've decorated our service extension with the annotation of a service extension, and that we've specified the service type of notification. The failure to decorate any extension with the service extension or server extension or other class-level annotation could result to processing problems within the Smart Cosmos market. The first thing that a notification service is going to do is extend an abstract service. Now, in our case, we actually extend abstract AWS service because we need that secret key, the access key, that information required to connect to the Amazon cloud. We also provide a unique static UUID and a human-readable name defining what the actual service is. In the case of notification services, there's a number of methods related to the concept of creating a pub/sub style message broker queue or topic. In our case, we create a topic with Amazon Simple Notification Services in the create topic. Similarly, in the subscribe method, we actually require information about the topic that we want to subscribe to, and we use the Amazon SNS classes to subscribe to that topic, in this case defaulting to the US East 1 region for that subscription. Ultimately, in the case of Amazon, there's a ability to also delete the topics. So we have a delete topic method that will take the notification endpoint and reach out through the Amazon SNS client and actually delete the topic. In some situations, the backend message broker may not support deletes, in which case it is acceptable for this delete topic to simply return without doing any work. Again, if the message broker does not support the deletion of a topic or permissions are not available, do not throw an unsupported operation exception or any other type of exception in the delete topic. Simply return without doing any work, possibly logging out the fact that this particular implementation does not support a delete topic. When it comes time to actually publish and to perform the integration with the third-party service, the notification endpoint, along with a string of JSON, is passed into the publish method. Here, again, we grab the SNS client for Amazon, and we take the JSON object. We look to see if there is an event type and construct a subject. This subject is very unique in the way that it's constructed. It may make sense in your notification service implementation to provide additional features where a template could be used to define what the subject looks like, using the template service inside of the service factory. There are lots of options that are available within the publish method itself once we get into the notification service. Like a good service extension, we do use the actual event service to record the fact that an event type of notification broadcast took place. Because of the potential disconnect, we know the account that was responsible for the broadcast, but we may not know the user. So in this particular implementation, we pass in a null to represent that no specific user performed this integration. Instead, it was a result of the overall performance of the system or the server itself. It also may be necessary to unsubscribe from a particular topic. Again, the similar pattern starts to appear. We grab the SNS client, we unsubscribe based on the notification endpoint's ARN, and we log that that notification was unsubscribed in the audit. It's again worth noting that your concrete implementation in your backend message broker may end up having a different set of permissions. If an unsubscribe is not possible, do not throw an exception. Simply log the fact that this particular concrete implementation does not support unsubscribe. Finally, the notification service interface also includes this concept of a confirm subscription method. In practice, not every private message broker will require this confirmation step. In the case of the AWS Simple Notification Service, it's required that the endpoint actually prove that it's permitted to receive the information. And it does so by allowing the Amazon service to send a subscription confirmation request to that endpoint. There's data within that subscription confirmation request that needs to be extracted, a token in particular, and sent back to the Amazon SNS client to confirm enrollment. In the case of the AWS notification service implementation here, we can see that we grab that token and confirm the subscription result and then audit that event out. In summary, the notification service was designed explicitly to work with pub/sub message brokers. As stated earlier in this YouTube video, if an iEvent broadcast notification service wants to be backed by something other than a pub/sub message broker, it is both permissible and supported for the iEvent broadcast notification service to take matters into its own hand and thus eliminate the need for a formal notification service. That said, a notification service class must be defined inside the object's UML. That object's YAML will allow us to actually put in there a log-only notification service or a dev null notification service that takes no actions when any of its methods are called. Here we can see an incredibly simple example of a sample visitor service. In fact, this is the equivalent of a hello world for a visitor. The sample visitor service extends abstract visitor, and it says that it wants to be visiting only visitable events. We could even change this out to be if we only wanted to visit, say, visitable files, or if we wanted to only participate in visitable devices. So the ability to use the generics to define what we're going to actually visit is an important part of the implementation of a visitor service. It's worth noting that a visitor service can only work on a single visitable type. It is not possible to have a single visitor class that processes multiple visitable types. Because it is a service, it does have to include a unique static UUID as well as a human readable name, but it also includes the entity reference type, and this must match and align with the particular visitable event or whatever that type was in the generics. So in other words, if we were to change the visitable event from, say, visitable event to visitable object address, then we would also have to change this entity reference type to be entity reference type of an object address. It's important to keep these in sync. Failure to do so will result in some unexplained behaviors. Finally, when the visit method is invoked from the iEvent service, it's passed its visitable event based on the generics of what was defined up here. In this example, we simply log out that the event was visited, but in practice, anything could take place here. It's imperative to remember that when the visit method is invoked, the actual record in the database has already been committed and cannot be affected by the visitor. Likewise, the visitor is typically on the other side of a blocking queue, so it's okay if this visitor has a little bit of processing to do or network I/O to invoke.